All right, guys, welcome back. This is going to be the 2.2 instructional video. And what we saw in 2.1 to rehash was equations of the form, let me back up. We saw equations in the form x minus 4 equals 2. Or maybe it was 3x equals 9. And what we did in each of those cases is we isolated the variable by using an inverse operation. We got the variable alone on one side. Again, if that's foreign to you, if you look at these and you're like, I don't really know how I would solve those, I would pause the video, go back and rewatch 2.1. Okay? So we saw those in the last, and we learned how to solve them using inverse operations, and that was great. But the question becomes, we can't just stay there, is how do we solve more complex equations? What if it has multiple steps? And that's what 2.2 is really going to be all about. Okay? So to solve two-step equations, we are going to isolate the variable as we've been doing. But the question is, how do we do this? Maybe it's more practical if I show you our first example. If I have 3x minus 2 equals 4, you look at this and you go, okay, I know I need to get the x by itself, but what I've seen in the past is either 3x equals 4, and I went, okay, well, I'll divide by 3 because the 3 is being multiplied by the x, and that'll get x by itself. Or you've seen x minus 2 equals 4, and you said, hey, I'll add the 2, and that'll get rid of the minus 2, and again, I'll have x by itself. But never have you seen them together. And the natural question that goes through the brain is, well, if I have both of these situations happening, which one do I do first? What do I do here? Well, we're going to learn how to solve that. So the two steps you want to follow is, in the simplest way to get the variable by itself, again, there are multiple ways to do it, is to move the constant first. We'll talk about what that means. And then multiply or divide what's attached to the variable. And what's attached directly to the variable by multiplication or division, specifically multiplication, is known as the coefficient. So what am I saying here? Well, by the logic I've used above here, what we should do is we should move the constant. The constant is a number not attached to the variable. Now we have two constants here. We have the 4 and the minus 2. I would be moving the minus 2 because, again, it's on the same side as the x. The 4 isn't causing me any problems. It's on the other side of the equal sign. It's the x that I want to get by itself there, so I don't want that minus 2. So I would move that first, and then multiply or divide depending on what's being attached directly to the variable. In this case, it's 3, so I would then divide by 3. So let me show you how to do that first, and then we'll talk about why we don't do it the other way. So maybe I'll go ahead and write over here the problem again, and you can, for those of you who are curious, who are inquisitive, who are like, wait, why would we do it that way? I'll show you. Okay, so let's follow my process first. Again, pause the video and write these steps down if you haven't already. So I want to solve this two-step equation. Okay, I'm trying to get x by itself. I want to know what value of x makes this equation true. Well, to do that, I'm going to have to manipulate the equation without fundamentally changing it. In other words, without making it untrue. Okay? Well, first, let's deal with the constant being this minus 2. Well, if I have a minus 2 and I don't want to have the minus 2 anymore, what I need to do is I need to find a way to eliminate it. In other words, I want to find out how to get rid of it. Okay, so how do I do this? How do I isolate the x by getting rid of the minus 2? Well, the opposite of subtracting by 2, as we saw in the last video, is adding 2. So I could add 2. Again, the logic there would be if I had 3x minus 2 and I add 2 to that, the minus 2 and the plus 2, well, that's just 0. we know that 3x plus 0 is 3x. So effectively, if you add the 2 in there, you are eliminating or canceling out the minus 2. But we learned that in order for this equation to stay equal, whatever you do to one side, you have to do to the other. So I will add 2 to the right side as well. As I just showed you above, or below, excuse me, the minus 2 and the plus 2 will cancel. I have 4 plus 2 here on the right side, and that will add to give me 6. 4 plus 2 is 6. So what I've done here is some people would say I've canceled out the 2 on the left side, I've added 2 to the right. You could also think of it as I've moved the 2 to the other side, right? The equation is still equal if instead of having a minus 2 on the left side, I have a plus 2 on the right side. So I effectively moved that 2 over is another way of thinking about it. But either way, I'm left with 3x equals 6. And again, I look at this and I go, well, how will I get the x by itself? Well, I will get the x by itself by looking at the 3x. We saw this in the last video. How is that 3 attached to the x? The 3 is being multiplied. If I'm multiplying something by 3, the opposite of that would be dividing by 3. Well, what I do to one side, I must do to the other. This 3 divided by 3 will ultimately give me the x by itself. Again, we talked about the logic of this in the last video. If I do that, what I could really break this down to is 3 is being multiplied by the x on top. And so what's really happening here is I could split this fraction up. Again, we know that 3 over 3 times x is the same thing as 3x over 3. Or rather, x over 1. Okay, and we know that 3 divided by 3, or any number over being divided by itself, is just 1. Well, 1 times x over 1 is just 1 times x, which is just x. And again, that's kind of the logic of why division is the inverse operation of multiplication. So I divide both sides by 3, and again, as I just showed you, the 3's will cancel. 6 divided by 3 is 2. And so now, by dividing by 3, the x is by itself, and according to my equation, x should equal 2. Now, if you think back to the last video, how did we check our work? Well, it's an equation, so both sides should be equal. And so if I'm articulating here that x is equal to 2, then if I plug 2 in for x into the original equation, I should, again, end up with a true equation, 2 sides that are equal to each other. So we can see that if we look and see if the left side equals 2. Or I'm sorry, 3x minus 2 equals 4. So I look at this, 3 times 2 is 6. 6 minus 2 is 4. And we have 4 equals 4. That is a true math statement. That is an equation. Therefore, our answer of x equals 2 is sufficient. Okay, so what you can see here, the big picture, 2-step equations. Move the constant first, that is on the same side as your variable, then divide by what's attached to the variable. Now, again, you may be wondering, actually, let me leave that there. You might be wondering, okay, well, Mr. Carter, why move the constant first? Why not divide by 3 first? Well, let's go ahead and try that. So if I want to divide by 3, what I'm going to have to do is divide everything by 3. I have to divide everything by 3. You're telling me, hey, why not divide by 3 first? Why move the constant first? Okay, we can divide by 3 first. That's fine. But I'll have to divide everything by it. Not just the 3 and the 4, which you can already see the 4 will become a nasty fraction, but the 2 as well. You might go, hold up. What? Why are you, when you add 2, like you see here, you only do it to the 2. Why would you divide the 3 by everything? Well, think about it like this. If I have 4 apples, and 2 oranges, if I have 4 apples and 2 oranges, and you say, hey, I'm cutting your apple supply in half. I want you to divide it by, or not your apple. If you say, I'm cutting your fruit supply in half, I want you to divide it by 2. What I would end up with was 1 orange and 2 apples. What you can see here is my quantity. If you tell me, hey, divide everything by 2, cut it in half, it applies to the apples and the oranges because they're both a part of my fruit supply. By the same logic, everything is divided by 3 in the equation above. If I say I'm going to divide by 3, well, that applies to everything on that left side. Whereas if you said, hey, I only want you to take away 2 apples. Okay, I took away 2 apples. Did that affect my orange supply? No, it didn't. Why? Because apples and oranges aren't like terms. Thus, when I add 2 to the left side here on the original equation, if I add 2 to the left side, it does not apply to the 3x because they're not like terms. Instead, it affects the constant. Okay, so again, that's why, if you want to learn more about that, again, I will sit down and talk with you about that. But that is why when we divide by 3, you're going to divide everything by it. But when we add or subtract by 2, it obviously only applies to the like terms. Okay, so either way, little tangent there. We're dividing by 3. And so when I do that, I'm going to get x, because again, we saw this earlier, right? Of 3x divided by the 3. Since everything's getting divided by 3, we know the 3's are going to cancel, so I'll just be left with x. But then I'm left with essentially fractions. Now, again, you can see here what I could do is I could add the 2/3 to the right side and get my answer, and it'll turn out to be the same answer. But it's not as nice working with fractions, which is why I recommend move the constant, then multiply or divide by what's attached to the variable. You could go the other way. You could do the multiplication or division first, but again, it's going to be nastier. You can see in black, I end up working with whole numbers. Okay, so again, some insight as to why we do what we do. Now that we kind of have a why behind it, kind of the logic behind 2-step equations, let's go ahead and do the practical side. Let's go ahead and solve some. Okay, 10 equals m over 4 plus 2. 10 equals m over 4 plus 2. Okay, so what I'm going to do here is I have a 2-step equation. I want to figure out what m is. So what do I need to do? I need to get m by itself. What's standing in my way? What's on the same side? Well, I have a divided by 4, and I have a plus 2. Now, according to my steps, as we saw earlier, the nicest way to do this is to handle the plus 2 first, move it to the other side, cancel it out on this right side, however you want to think about it, and then we'll work with the m. Well, I have this plus 2. I no longer want the plus 2 there because I want to get m by itself. The opposite of adding 2 is subtracting 2. Again, those will zero out, leaving me with, on the right side, just m divided by 4. But you saw instinctively, once I do it to one side, I must do it to the other. 10 minus 2 is 8. And therefore, we have removed the 2 from the right side and moved it to the left-hand side in the form of a negative 2. If it's a positive 2 on the right-hand side, it would be a negative 2 on the left-hand side to keep the equation. So what I'm going to do now is I have m over 4. When I see that m in the numerator of the fraction, I realize that the It's being divided by the 4. The opposite of division, the inverse operation, is multiplication by 4. So I multiply both sides by 4. What that will just leave me with, again, I'm just doing the shorthand here. I've shown the math earlier as to why 4 times m over 4 equals just m. Again, they're inverse operations. And again, if you want to see the math, look back in previous video. 4 times 8 is 32, and I find out that m equals 32. Again, we can check our work. If this is the case, then when I plug in 32 for m, if m is indeed a solution to the equation, or 32 is indeed the solution to the equation, then when I plug 32 in for m, should make both sides of the equation equal. 32 divided by 4 is 8. 8 plus 2 is 10. Both sides of the equation are equal. My answer works. Okay. Now, again, here is a good point to check yourself to see, hey, am I getting this? Am I understanding what is going on? Am I comprehending two-step equations? So I'd encourage you to pause the video, try this on your own, and see if you are understanding. Okay, at this point, I will solve it. Check your work with mine. We have negative x plus 6 equals minus 11. And before I do anything, I don't know if you did this when you tried it on your own. It looks a little funny to me that we just have a minus sign here, minus x. What does that mean? Well, hopefully you know in your time in pre-algebra, maybe you don't. If so, this will be a good refresher, that when we don't see a number directly in front of a variable, if it doesn't have a coefficient, we assume a 1 is there. When we just see a minus in front of the variable, that means the coefficient, the number attached to the variable directly by multiplication, is minus 1. So when I see minus x, I'm just going to go ahead and rewrite that. Actually, I won't really rewrite it. I'll just rewrite it down here as minus 1x, just for a visual to help me understand what's going on. Well, when solving two-step equations, according to what we've been doing, it's easiest if I move the constant first, and I want to get this x by itself so that I can find out what it is. So I'm going to go ahead and subtract 6 from both sides, 6 being the constant on the same side as the x. I'm choosing to subtract 6 because that will zero out with a positive 6. On the left side, that leaves me with negative 1x, and on the right side, that leaves me with negative 17, negative 11. If you take away 6 more, it becomes negative 17. Now I look at what's attached to the x. I see a minus 1 is attached to the x by multiplication. The temptation is going to be when you see this is maybe to add 1, but I don't want you to add 1 here. I don't want you to add 1, just like you would if there was a 2 or a 4 or a 5 there. You would divide by 2, 4, or 5 because it's being multiplied by the x. Similarly, the negative 1 is being multiplied by the x, so I want to divide by negative 1. I divide by negative 1. Both sides. On the left side, because that's an inverse operation, it's just going to leave me with x. And on the right side, I have negative 17 divided by negative 1, which gives me positive 17. Again, check my work. Plug 17 in for x. Negative 17 plus 6 equals negative 11. And you check that in your calculator, you get negative 11 equals negative 11. That is a true equation. Therefore, 17 is a correct solution for x. Okay, let's do one more example. And this will be the first word problem we've ever seen together. And I don't know what your experience has been in math. Maybe you're someone who likes word problems because you see them as more applicable. Maybe you're someone who sees word problems and runs the other way. You're like, I don't want anything to do with that. I never understand them. I never know how to solve them. Let me be the encouragement and teacher to you to show you how to do word problems, because word problems don't need to be scary. They really, really don't. Word problems are the exact same as the other types of problems you do. They just have one additional step. And that additional step is setting up the equation, problem, whatever it is you're working on, and then using the math tools you know how to solve them. Okay, so let's work through this one together. You are ordering tulip bulbs from a flower catalog. You have $14 to spend. One bulb costs 75 cents. Shipping is $3. How many tulips can you buy? Okay, so the first things first is I'm going to identify key pieces of information. I have $14 in total to spend. I have the cost of one bulb, but based on the question, how many tulips can I buy? I'm looking to probably have more than one bulb. But I don't know the cost of, say, 2 bulbs, 5 bulbs, 7 bulbs. I can figure it out based on the cost of one bulb, but I don't know how many I'm going to buy. And I know that shipping is $3. Okay? Well, what I always do when I look at word problems or these types of problems is I look to see what's happening, and then I look to set it up. So let's see what's going on here. Well, I have $14 to spend. I have $14 I can spend, and I'm going to spend it on tulip bulbs. And if you know anything about money, you know that the amount you spend has to equal how much or be less than, but we're not going to deal with inequalities quite yet. So we'll just say equal. The amount you spend has to equal how much you have, right? The amount we spend has to equal how much we have. Well, I have $14. That's how much I have to spend. So we're going to try and spend $14 and get as many tulips as we can. So what we have so far is we have how much we have. That's the 14 here. What we need to figure out is how much can we spend? Okay, how much can we spend? Well, it's going to be made up by the cost of the tulips. So if we have this $14 and it's being made up by the cost of the tulips, let's go ahead and figure out in a way we can write the cost of the tulips. Well, I see 2 pieces here. I see one bulb costing 75 cents. But again, based on the question, how many can I buy? I know one bulb is 75 cents. Well, if one bulb is 75 cents, you could probably tell me that 2 bulbs is $1.50. That 3 bulbs is $2.25. That 4 bulbs is $3. How are you doing that? What you would do is you would multiply. If one bulb is 75 cents and I wanted 5, you're going to multiply the number you have by the cost per bulb. Well, I don't know how many tulips I'm buying. And when we don't know something in math, we put a variable there. Okay, we put a variable there. So the first part of the money I'm spending is going to be on tulip bulbs. And they're 75 cents a piece. And I am going to multiply that by how many I end up getting. Again, the logic being, if I want 5, then 5 times 0.75 will give me how much I'll spend. So over here, just to make sure I know what's going on, I'm going to label what X stands for. X is the number of bulbs, which we don't know quite yet. So we're putting a variable there. Kind of stands in place until we know what it is. Now, is that the only thing that makes up the cost of the tulips? Well, no, I'm ordering them from a catalog, and shipping is going to be $3. So I can't just buy $14 worth of tulips. I also have to account for shipping. Now, there's no indication that shipping changes based on how many tulips I buy. It's just $3 to ship them. So we will add 3 to the money we're spending on the tulips. I'm spending the 0.75 times however many I buy. That's going to give me how much money I'm spending on tulips plus my shipping, and we know that can't exceed and ideally will equal $14 because that's how much we have. So this is how we can deduce information and set it up in an equation. And now when you look at this equation, maybe I'll box it in red, help visually. Now that you see this, you go, oh, I can probably solve that. I've done pretty well with the ones above. But maybe you struggled to come up with that on your own. And if that's you, let me encourage you. We're going to practice this a lot. We're going to get better at it. I will work with you. I will help you. Okay? But don't be afraid of word problems. They are just normal problems with some context to it. So we have to set up equations or inequalities, different things before we solve them. So without further ado, let's go ahead and solve it. Let's go ahead and solve it. Because we still need to answer our question, how many tulips can we buy? We know this equation will represent it. I can't go over 14 bucks. 75 cents a tulip bulb, $3 for shipping. Well, if we want to find how many tulips we can buy, and that's what X represents, we need to get X by itself. Where do we start? Well, let's subtract 3 from both sides. We always like to move that constant first. Makes life a little simpler. So I subtract both sides by 3. Because that's an inverse operation. It'll cancel out on the right side. On the left, I'll have 11. From there, I have this 0.75 being multiplied by X. So the opposite of multiplying by 0.75 will be divided by 0.75. When I go ahead and do that, I don't know that in my head, so I'll do it in a calculator here. I get 14.66, and I'll round it off to 7. Equals X. And this is where what I did on the right becomes really important. Sometimes you'll get to the end of the word problem and you'll go, great. And it'll say, what's your answer mean? And you'll go, I don't know. Here's how you remember. Accurately label your variables. I got 14.667 equals X. Well, that means, what is X? That's the number of tulip bulbs I can buy, okay, with my $14. There's one problem here. Can you buy 14.667 tulip bulbs? No, of course you can't. You can only buy 14 or 15 or 16. You can't buy partial tulip bulbs. That's why it's also important to label. So you see if your answer makes sense. Well, 14.667, and we go, okay, I can't get that. That's the max I could get with my money. I could get 14.667, but I can't get a partial. So traditional math would tell me, well, that's 0.667, round up to 15. But what's the problem with that? Well, if I round this up to 15, I'm going to exceed my budget. If 14.66 was the cap, that's how much I could get without exceeding my $14. Rounding up is going to cause me a problem. And what will show you that is if you check your work. Okay, if 14 is how much I can spend, and we plug 15 in for X, 0.75 times 15 is 11.25. Plus 3, that's 14.25. I don't have $14.25. I've only got $14. So you need to round down in this case. You might go, what? Why are we rounding down? Well, because of that logic right there. We can't exceed our $14. So if 14.667 is the max number of tulip bulbs I can get for my money, then guess what? I'm only buying 14 bulbs. Now, again, I went into a lot of explanation there, took a lot of time unpacking that problem. You might go, holy cow, word problems are complicated. Trust me, they'll get easier as we practice them. But you just have a couple added steps in word problems. The basis of this is the same as the problems we did above. We just had to set up the equation and we had to do a little bit of interpreting at the end. So what do you need to walk away with? What's the big idea? Well, what you need to walk away with is we're going to begin working with more complicated equations. Specifically, we started working with two-step equations today. And the easiest way to solve a two-step equation is to move the constant, then either multiply or divide, depending on how your coefficient or what type of coefficient is attached to your variable. Thanks for watching. As always, let me know what questions you have.